So because the lowest energy is naught, we are going to write the ground state. So we were writing this as E naught, but let's just plug in the value. So this will be naught, okay? So then we can very easily write the state with energy omega. This will be proportional to A dagger on naught. The state 2 omega will be proportional to A dagger on omega, which is proportional to A dagger squared on naught. And the state n omega will be proportional to A dagger to the power of n on naught. So we give the state n packets of energy. We act with A dagger n times. Now, the reason why I was saying proportional to here is that these states are not normalized. So let's now work out how to normalize our states. Okay, so what would we like? Well, we would like that if we take bra n omega onto ket n omega, that's 1. That's what we mean by saying our state is normalized. So let's start off with a normalized state n omega. And let's study the state n omega plus omega. This will be some constant number, which we're going to have to figure out. And then A dagger acting on n omega. So that's the equation for the kets. Let's dagger this. So daggering turns ket n omega plus omega into bra n omega plus omega. It turns ket n omega into bra n omega, and it turns the A dagger into an A. Remember, you reverse the order of the factors. It will also complex conjugate this constant, and since this is a number, I can take it up front. Okay, so that's what I get by daggering. So now, what would I like? Well, I would like n omega plus omega to be normalized. So that means bra n omega plus omega into ket n omega plus omega. I want that to be 1. And I can calculate what this value is by using the 2 equations above. So if I multiply these two, Cn star times Cn is the mod of Cn squared. Then I've got bra n omega, I've got A dagger, and then I've got ket n omega. So I have to evaluate this. So how can I evaluate it? Well, remember that the commutator of A and A dagger is equal to 1. Okay, so we've worked out that that commutator is 1. So the commutator of A and A dagger is equal to 1, but this is just A dagger minus A dagger A. So that means A dagger is equal to 1 plus A dagger A. Now, why is this a useful formula? Well, A dagger A is nothing but the Hamiltonian divided by omega. Okay, so look at this equation sitting over here. A dagger A is just the Hamiltonian over omega. So this is nothing but 1 plus the Hamiltonian over omega. And the reason why that's a useful fact is that I know that the Hamiltonian acting on the state n omega just gives me the energy of the state, which is n omega onto n omega. Good. So now I've got 1 is equal to the mod of Cn squared n omega. Now, instead of A dagger, I'm going to write 1 plus the Hamiltonian over omega into n omega. So this gives me mod of Cn squared. Then I've got n omega. So that's coming from the 1. And then I've got plus n omega h n omega over omega. That's coming from the h. This is the mod of Cn squared into 1, because n omega is a normalized state, plus, then h on n omega is just going to give me n omega, divided by omega is n, and because the state is normalized, that's it. So this tells me what Cn is. So Cn is 1 over the square root of 1 plus n. This is not the most general solution. I could have included an arbitrary complex phase, but including this phase, I don't get anything for being more general. So I'm just going to take Cn to be 1 over the square root of 1 plus n. So now we have that n omega plus omega is equal to a dagger over the square root of 1 plus n acting on n omega. Okay, good. You can go through a very similar computation to prove that n omega minus omega is equal to a over the square root of n onto n omega. So try to see if you can prove that equation. I think you'll be able to. And then another equation that I want you to try to prove. Again, you know enough to prove this. So try to see if you can prove this. Is that n omega can actually be written as a dagger to the power of n acting on the ground state, and the correct normalization constant has got a square root of n factorial sitting there. So this is the key result we wanted, that formula in the blue box, and it tells us what is the energy eigenstate. Good. We will continue in a moment.